comes the recording. And there's my thing. Okay. So the thing that we did not hit before we wrapped up logarithms, and I think it was just a matter of running out of time and that kind of stuff, was we did not talk about the change of base formula. Okay. So this is the change of base formula right here. My pen is not going to work. There we go. Okay. Log base b of m. So whenever I have a base or a logarithm in a certain base, and you say, you know, I really don't like it in base 3, or I really don't like it in base 5 or whatever, I want to change that to a different base. It's called the change of base property or the change of base formula. And so you can change it pretty quickly by using this formula. So I tell people, look at, sorry, that was focusing on my hand. Look at the fonts. We're going to talk about the log base answer, where the answer here is the big font, okay? And so that guy is going to go on the top, okay? The big font, okay? Not the big number necessarily, but the big font. And the base, the old base that I don't want anymore, it's going to go on the bottom. So we're going to do this change, log base A of M, where A is the new base. So if we want a new base, then we're going to do this. Log whatever base I'm looking at of M, where M is the answer. M is the large font guy right here. Okay. And we're going to divide it by log base A of B. Okay. Where B is the old base. Okay. That we're getting rid of. Okay. So I have an example. I already worked it out here. I actually started to do this as a video, and that's when the technology died on me last Friday, so I couldn't get it to work for me. But if we have log base 3 of 27, and we want to make it into a base that I know, or I can punch on my calculator instead of using these weird logs that I don't know. Okay, I don't know log base 3. I can't do that in my calculator very easily. Then the answer is use this formula. So we're going to change it to base 10. And so it's going to be log base 10 of 27. Where 27 is the answer. It's the big font number. It goes right there. Divide by log base 10, because I'm trying to go into the new base of 10 of whatever the old base was. So here it was a 3. Okay. And then we happen to know that what that exponent is going to be is a 3, because 3 to the 3rd power gives me a 27. But if you punch that on your calculator, the log of 27 divided by the log of 3, it will give you a 3 as your answer. So that's what that looks like. So real quickly, what if I wanted this to be log base E? Because E is the other one that my calculator knows. Okay. So a log base E, that's the natural logarithm. That's going to be ln, right? So ln of 27. Still the bigger font number, whatever the answer was, right? Log of 27 divided by log of 3, ln of 3. So what you see with this particular formula is, even though if I punch log base 10 of 27 on my calculator and I punch ln of 27 on my calculator, I'm going to get 2 different answers, right? Those are not the same. But what we see is that the ratio here remains the same between these. So if I punch it with a base 10, and then I punch it on my calculator with a base E, log base E, ln, it does not matter. The ratio is still the same. I'm still going to get a 3. Okay. So our answer here, no matter which one you go for, is a 3. So what I see is a lot of people go, well, I'm just going to always use ln or log base E, because that way if I've got E's, it'll take care of the E's. If you don't have E's, if you have base 3 or base 4 or something like that, it still works. So a lot of people are just like, I'm just going to use ln. So feel free to just use ln if you want. And of course, you have that button on your calculator. So the ln button is there. No worries. Okay. So that's the one thing. As I was looking back, I thought, oh, we didn't quite get this change of base formula thing in the logs. So if you run across that in the homework, then you'll see it and you'll be okay, no problem. Got it. Should be able to do all of that logarithm and exponential homework now. So I think it was chapter 4. Are we good? All right, so off of the videos that you should have seen while I was gone, solving linear equation systems. They'll call them systems of linear equations. You'll hear that. But that's what we're going to solve is the systems of linear equations. Then hopefully you saw some stuff on those videos and you were able to follow it that looks something like this. We're going to solve 3x plus 2y equals 4 and 2x plus y equals 1. Okay, that's my system. And you know it's a system because it has that big, huge curly Q bracket on it, right? Okay. The only thing you really need to kind of check before you get started is that in this first position is my x's, in this second position is my y's. If for some reason they're rearranged, then you need to rearrange those equations before you start solving them, right? Because I saw some of those in the homework and in the book where they had like, it was y equals 3x plus 5 or something like that. So, okay, that's great that they've got it solved for y equals, but you may need to rearrange them, okay? So there's two different ways to do these. You can solve them using either substitution, right? Hopefully these were our methods. Substitution. Okay. And in this case, I might actually use substitution because I might solve for y because it's all by itself here. It doesn't have a coefficient on it or anything. I could just say y equals 1 minus 2x and solve for the y. And then I could substitute that in. That's one method. And the other method is elimination. Okay. And then the elimination method, what I do is I multiply one or both of the equations by a constant to try to cancel one of the variables out, right? So which method do we want to do here? And I don't care. Should be able to do either way. Nobody cares. Okay, let's do it both ways. Let's do it both ways, okay? So first we'll do and then this will just be our example, for both types, okay? For substitution, what I need to do is solve for one variable in one of the equations. And like I said, this second equation has that y with no coefficient, so it's kind of nice for that. So let's go ahead and solve that second equation, y equals, get the y by itself, 1 minus 2x, right? If I subtract the 2x off of both sides, that's what I'll have. Okay, so solve for one variable and substitute into the other equation. That's what we're going to do for this. Okay, so that means that I'm going to take this guy we just got, 1 minus 2x. If you want to put the negative 2x first, you can. I'm going to take him and I'm going to substitute him into the first equation up here, right? Okay, so that looks like this equation right here. Starts with 3x, so didn't do anything to that. 3x plus 2 times, but instead of that y, I'm going to substitute. So I'm going to put parentheses. And it's really important you put your parentheses, especially when you got negatives in there. Okay, I'm going to put parentheses, and instead of the y, I'm putting in this guy, right? Okay, so this is my substitute. This is what I'm going to plug in. So I'm going to put in 1 minus 2x. So it was y, but now I put in the 1 minus 2x. All that equals 4, right? And hopefully if we substituted properly, then both of these variables will be an x now. So I should be able to just solve those. 3x. Do it the way we've always done it. This is just linear equation. So 2 times 1, oops, I'm sorry. 3x plus 2. I don't know where I got that extra variable. Plus 2. And then the 2 times the negative 2x gives me a negative 4x, right? So I'm just distributing that 2 through. So 2 times 1, 2 times negative 2x, and all that equals 4. All right, and now I look and I say, hey, look, I got a 3x and a negative 4x. I can combine like terms. 3x minus 4x is a negative 1x. Plus the 2 equals the 4. And then we can solve because we can say, well, subtract 2 off of both sides. Negative x equals 2. And then solve for x completely. Divide by negative 1, right? It's got that negative out in front of it. So I want to get rid of that negative sign. So x equals negative 2. Because what I do to one side, I do the other. So I've got a negative 2. All right. So then whenever I'm finished and I have x equals negative 2, again, I should be able to substitute back in. You can go to any of these 3 equations you want to, but I like to pull this one that I actually have the y solved for. Y equals 1 minus 2x. Because I already solved it for y, I might as well use it and substitute into there because it'll be nice and pretty when I do that, okay? So y equals the 1 minus the 2 times the negative 2. Substitute in, instead of x, a negative 2. So minus 2 times negative 2, 1 plus 4, right? And that's going to give me y equals 5. Okay. So in your book, they're probably going to ask you to do this as if it was an ordered pair. Okay, so watch out for that. They probably want you to say that this solution is negative 2 and positive 5. And so that is going to be probably the final answer that they ask for when you do your homework. Give it as a point, give it as an ordered pair. Okay. If you want to double check yourself because I noticed some of the homework questions say, is this a solution for your system of equations? Then you need to go back to one of the 2 originals, right? Actually, technically, you should do both of the originals and substitute in negative 2 and positive 5 and make sure. So 3 times negative 2 is negative 6. Negative 6 plus 2 times 5 is 10 equals 4. Yep. 2 times negative 2 is negative 4 plus a 5 is a 1. Yes. Okay. So that's how you know this is a solution for both equations, is because you plug it in, it works. Okay. So does that sound familiar? Looks like the substitution that was on that video, I hope. Okay, good. And the other one is elimination. So I think we can do that one fairly quickly. So I'm going to rewrite my same system. 3x plus 2y equals 4. 2x plus y equals 1. That's my system. And we're going to do it using elimination. Okay. And again, I kind of look here and I say, hey, that y is by himself. He's a positive 1. And up above here is a 2y. So I think, what can I multiply this second equation by that will make that cancel? So if I have a 2y here, I need a negative 2y here for them to go away. So I'm going to multiply this second equation by negative 2. Okay. Now the whole equation. So get it all in there. Put parentheses, whatever you need to do. So what I'm going to have is 3x plus 2y equals 4 for the first one. And for the second one, I'm going to have negative 2 times 2x is negative 4x. Negative 2 times the y is minus 2y. And negative 2 times the 1 is equals negative 2. All right. And the idea is, if I did it right, if I picked the right number to multiply this second equation by, then these guys will go away, right? When I add these, I'm going to add the 2 equations. When I add them, then that y, the y, 2y and negative 2y, those go away. So 3x plus a negative 4x is a negative x is equal to. And 4 minus 2 is 2. And that looks amazingly like what we did up above, okay? We had this negative x equals 2 here, right? And so to get that x completely by itself, we just divide by the negative 1 again. X equals negative 2, okay? And then we can substitute back in to get our 5. I'm not going to necessarily do that, but, you know, stick it into one of those equations. It doesn't matter, okay? So... Okay, I'll do it. 2 times negative 2 plus y equals 1. We got -4 plus y equals 1. Add the 4, right? Y equals 5. Okay, there we go. Just so we can make sure we did it. So the elimination a lot of times is very quick if you have them set up where you can get rid of one of the variables pretty easily. Okay, so hopefully that looks like what you did. That's just a recap. I hate that I was gone for a couple of days, so it left you guys on your own, but any questions about that, or we're okay? We're okay. All right, thumbs up. I like thumbs up. Thank you. Okay, so as I look through, I see that you've got homework in 5.1 and 5.2. You should be able to do that. I don't know if you have the 5.5 homework or not. I'm going to skip over that for now. It is solving systems of inequalities. If I get in there and I see that there is homework on it, then I will probably give you a short video on that. But I'd rather spend my time on still solving more equations and doing stuff that's going to be similar vein to what we just did. So the next section is section 6.1, which is matrices. And it's called matrix solutions to linear systems. Okay. So maybe you've seen this in like Algebra 2 before, I don't know, but if you haven't, then here we go, it'll be okay. A matrix, the way they work is, it's a nice way for me to work with a system of linear equations, especially when it gets big. When we have, so the one we did just then was 2 variables, 2 equations, but when we get 3 equations with 3 variables, that's when it starts getting bigger and a little bit more cumbersome to work with and a little more difficult when you're dealing with just the equations. So the matrix is a way for me to work with those things without using all the variables, which kind of ends up being nice for us. So for instance, here's our example. We have a system of equations that looks like 3x plus 1. I'm so sorry. I'm trying to make sure. Give me just a second. Nope, I lied. Let me grab this other system of equations for us. Okay. Oh, this one is also 3x. That's funny. Okay. 3x plus 18y minus 12z equals 21. Okay, that's my third variable in there, the 12z. X plus 2y minus 3z equals 5. And negative 2x minus 3y plus 4z equals negative 6. Okay. So like I said, a lot more difficult. All of a sudden, immediately we have more crazy stuff going on there, right? So, okay, this is my system. I don't want to have to deal with this and try to do things like add these two, see if I can get rid of the z, add those two, see if I can get rid of the z, work with other equations, all that kind of stuff. So instead, I'm going to go straight into a matrix. And what a matrix looks like is a big hard bracket. Okay, so, and then we're just going to pull out the coefficients. So I'm going to pull the 3, the 18, the negative 12, and the 21. So this is what a matrix is normally going to look like when we're doing these things. So I'm going to have this big hard bracket, and I'm going to have 3, 18, negative 12, and then they're going to draw a vertical line here. Okay, the point of the vertical line is it lets me know on the left-hand side is all my variables, right? Variables. And on the right-hand side is the numbers that were just constant, the equals part, the answers, right? So on the right-hand side, I'm going to put my 21. And then I'm going to close my hard bracket. Okay. So a matrix is just a big group of numbers is what it ends up looking like. So, okay. So what's the second row going to look like here? What's the coefficient for the x variable? It's a 1, right? Yes, ma'am. Good. Okay, so there's a 1 there. So this is going to be a 1, a 2, a -3. And then on the other side of the vertical line, we put the constant that's all by itself, the 5. Okay. And then the third row is, look at it, -2, what? -3, a 4. Oops, let me put that in line. A 4 and a -6. Okay. So that when I'm done, I can look at this column right here and I can say, that's my X column. Okay. Everything in this column, the 3, the 1, and the -2, those were the coefficients for all my X variables. Okay. And then I can look at this column and I can say, that's my Y column, right? That's the 18Y, the 2Y, and the -3Y. And then I can look at this one and I can say, that's my Z column. -12Z, -3Z, 4Z. So we can always go back and pick those things up. And the last thing, the one that's by itself, that's just a number. So that means that I'm not going to move anything out of the column it's in, right? All the first guys are always going to be my X's, then my Y's, then my Z's, then my constant numbers off by themselves. So that's what a matrix is going to look like in general. Okay. And then we're going to use something. Excuse me, I'm so sorry. We're going to use something that we call Gauss-Jordan. So it's a specific method, the Gaussian method, you'll hear it called that. And what it looks like is this. We are going to, well, the Gauss-Jordan is even more complicated. We're going to use Gauss first, okay? We are going to find this diagonal right here. Okay. It's the first X, it's the second Y, and it's the third Z. So the 3, the 2, and the 4 in this case. But it's always that diagonal. It starts here, so ignore the numbers for a minute. If you ignore the numbers right there, you have a 3 by 3 square, right? Okay, so it's always the middle diagonal, starting at the top left, working to the right, okay? We're going to figure out how to make those things be ones, okay? And there's a specific order we're going to do it in. I'll show you in a second. And then underneath that diagonal, I have this little triangle of numbers here. Okay, the 1, the -2, and the -3. We're going to make those guys look like zeros. Okay, we're going to do very specific. They're called row operations. Okay, so this diagonal will be ones. Ones when I finish. Okay, and this triangle, these I'll say these 3 will be zeros when we're finished. Okay, that's called the Gaussian method, G-A-U-S-S-I-A-N method. And Gauss was a very famous mathematician back in the 1700s. So it's been quite a while for him. Okay, he lives on today. Gaussian method. So we're going to do that. Okay, so here are the things that are called row operations. These are the legal moves, so to speak. And the reason they're legal moves is because if I do these moves, I'll literally call them legal moves. If I do these moves, it's the same as if I was working with these as equations. So for instance, does it matter if this guy is on the first row, the first equation, or if this guy is on the first row, the second equation? No. It does not matter the order in which I write my equations, right? So I can move these around. In other words, I can switch. It's called interchanging a row. And wouldn't it be nicer for me to have a 1 starting out if I had the second equation on the first row? Because he already has a 1 in the first position, right? And I want that first position to become a 1. So the legal move number 1, you can switch 2 rows as long as you switch the entire row. Okay, switch the whole thing. You'll be okay. What you can't do is just move the X's but don't move the Y's, or just move the variables and not move the numbers. Okay, so let's look at what that looks like in the matrix. Okay, so right now it's a 3, an 18, and a -12. I'm going to use this notation, the little arrows back and forth. okay, to indicate that I'm going to swap them, okay. Your book has a lot of, it'll say stuff like, your book says row 1 is swapped with row 2, okay. So they have a lot of variables that they start talking about. Row 1 and with the little arrows. I'm just going to use this notation right here. Okay, so what's that look like now? That's my question. It's still a hard bracket. Everything on the second row goes to the top. So that's a 1, a 2, a -3, your hard line, your vertical line, and then we've got a 5, right? So just be really careful that when we do that, that everything stays together. The 1, the 2, the -3, and the 5, okay? And when I swap them, that makes the 3, the 18, the -12, and the 21 go to the second line. Okay, that's what I mean by interchange or swap them. Okay, and then we didn't do anything at all with the third row, so it just stays the same: -2, -3, 4, and -6. And this is what I'm going to say about matrices. They take up a lot of space. Okay, so make sure you have plenty of room on your paper to be able to work with them. However, okay, they take up a lot of space, but they're not going to be horrendous to do the math. The math is going to be like, okay, I've just got numbers and I'm going to do multiplication and stuff like that. Okay, so that's the first legal move. No problem. You can swap them. Okay. The other thing we can do, and we're about to do legal move number 2, is remember when we were just doing that system of equations and we wanted to eliminate something? Like say, if I wanted to eliminate this x, I could multiply this whole row by -3 and then add these, right? That's what we just did when we did elimination. So the process would be figure out what I can do to get a 0, or we're going to look for zeros. Okay, figure out what I can do to get a 0, or figure out what I can do to get a 1 in one of those positions, and then multiply and add. So legal move number 2. Number 2, multiply a row by a number and add it to a different row. Okay, and because order doesn't matter here, the first equation, the second equation, the third equation, their placement doesn't matter, I can do this with any of the rows and add them to any of them. So here's what I'm going to do. I'm looking right here and I say, hey, look, this is a 1. This is the reason we want a 1, by the way. This is a 1. I can multiply 1 by any number, and if I pick it right, I can add it to the second row, and I can get rid of that 3. Okay, so when I'm done, add it to a different row and replace the other row. When I'm done, I will have eliminated one of my variables if I've done it right. Okay, so in my head, I'm thinking, look, this is a 1. I want to get rid of a 3, okay? That means I want a -3 because -3 plus 3 is 0. Does that make sense? Okay, so think, what can I multiply that first row by that will give me a 0 there in that position? Now, here's the trick. I'm not going to change the first row, okay? I got the 1 there. I want him to stay. So he's staying. So what I do is I go ahead and I write that first row because I don't want to get confused and accidentally change them by multiplying by -3 or something like that. I'm going to multiply by -3, but I am not going to change row 1. I'm going to change row 2. Okay. So here it is. We're going to, the notation I use for that is out in front of it, I'll write the number I'm going to multiply it by, and I'm going to do an arrow down. Okay. So -3 times the first row, and I'm going to add it. So you can think add if you want to. Add it to the second row. Okay, let's do it. -3 times 1 is -3. -3 plus 3 is 0. That's what I'm after. I want that 0 there, right? Okay, but I can't just do it in the first position. I got to do it all the way through. So let's go. -3 times the 1, -3 times 2, that's -6. Okay, -6 plus 18. This is kind of going to hopefully remind you of synthetic division, right? -6 plus 18 is going to give me a 12. Okay. And then one more. -3 times two more actually. -3 times -3 is a positive 9. 9 plus 12 gives me -3. Okay. So I've got all my variables done there. I need to do it with the whole numbers as well, the constants at the back. -3 times 5 is -15. -15 plus 21 is -15 plus 21 is a positive 6. There we go. All right. So look, I got the 1 that I want. I got the 0 that I want. Yes. Okay. So the order that I do these in is I always get this first guy as a 1, and then I always get the 2 guys underneath him as 0s. Okay. So I'm going to use this 1 to make the bottom guy here a 0 as well. Okay. So that requires me to do the process we just did again. Okay. So let's think about that. If I want, I'll do it up here. Okay. We already did the -3, so we're done with that. If I want a 1 times something and I'm going to get rid of a -2, then I want a 1 times 2. Does that make sense? Because 2 plus -2 is going to be a 0. All right. So I'm going to multiply the first row by 2. You can do it here if it helps. I'm going to multiply here and add there. That's fine. Multiply the first row times 2. Well, 2 plus -2, that's 0. That's what I'm after. Yay. 2 times 2 is a 4. I'm going to add that to a -3. 4 plus -3 is 1. Okay. 2 times -3 is -6. Plus the 4 is -2. All right. And then 2 times 5 is 10. And I'm going to add it to this -6. 10 plus -6 is a 4. All right. So, yay. I've got a 1, I've got a 0, I've got a 0. All right. And believe it or not, we're almost there. Okay. So, when I look at this guy, here's my new matrix. I'm going to get rid of the old stuff. I'll bring it back in a second, but I don't need it right now. When I look at this guy, remember my goal. I want 1s on this diagonal, and I want 0s down here. Okay. Look right here on this third row. Okay. Look at that 1 we just created. I love that 1. Okay. In my head, I think order doesn't matter. I can switch these. So my next step is going to be to switch these 2. Just swap them. Okay. That's all we're going to do. Okay. So here I go. I'm going to move these around. 1, 2, -3, and 5. That one, the first one, I'm leaving alone. These 2 I'm going to swap. So I'm going to put this guy 0, 1, -2, and 4. And then I'm going to move the second row to the bottom. 0, 12, -3, and 6. So I'm just using that first legal move again, right? I'm so sorry. All right. So what that does is, hey, now I've got 1, 2, 3, 4 of what I want. I still want a 0 here, and I want a 1 there. Okay. So we're getting close, believe it or not. Okay. I'm going to use legal move number 2 again. So I see that if I multiply this 1 right here, I'm done with row 1, by the way. I'm never going to touch row 1 again until we get to the solution part. Okay. So I'm going to work off of row 2 and row 3 because those are the ones I'm trying to still make stuff happen. If I go back to row 1 and I multiply it by stuff, I'm going to get rid of 0s. Okay. I'm going to undo some of the work I've done, and I don't want to do that. Okay. So I'm going to work off of row 2. Okay. And I'm going to say, hey, if I multiply this guy by a -12, I'll get a -12 here, and I'll get -12 plus 12 will give me a 0 right here, right? So I'm going to add it to the bottom row. All right. So leave row 1 alone. 1, 2, -3, 5. Leave row 2 alone. We're not changing it. 0, 1, -2, and 4. Okay. But we're going to work off of row 2 to get stuff to happen to row 3. Okay. Because that's where I still need this to be a 0 and this to be a 1. That's where I am. Okay. So as I look at that, I say, okay, 0 times -12, it doesn't matter. That's why I'm working off of row 2, because I have a 0 there now. Makes my life easier. So 0 plus 0 still is 0. We're not wanting to change that. We want it to stay a 0. Okay. But -12 times 1, oh, I did this. I multiplied there, I'm multiplying there. -12 times 1 is -12, plus 12 is a 0. Yay, that's what we're after. -12 times -2 is a positive 24. 24 minus 3 is 21. Okay. And then the last one here is -12 times 4 is -48. -48 plus 6 is -42. Okay. And if you need to do what I just did, which is go off to the side and do some arithmetic, some scratch work, or use your calculator, whatever, that's great. No problems. Okay. So we're almost there. We have our zeros. We need one more one. Okay. So that enter rule number 3. Okay. Legal move number 3. Legal move number 3 says I can multiply any row by a non-zero number. By the way, up above, we didn't want to multiply by 0 either, right? So I didn't say it wasn't 0, but it's a non-zero number. So you can just multiply. You can do that in an equation, right? What I do to one side, I do to the other. As long as you multiply everything by the same number, we're good, okay? So here I say, look, it's 21. I want that to be a 1. So it's a little tricky. I'm going to multiply it by a fraction, 1 over 21. Okay. And that will make it happen for me. So you just have to think about, oh, I want to divide by 21, right? But we're multiplying, so that makes it a fraction. So the first 2 rows don't change. When I multiply, so write the first 2 rows down again. When I multiply here, 0 times that guy is a 0. The other 0 is still a 0. But 21 times 1/21 is a 21 over 21, right? So that's a 1. Ta-da, that's what I wanted. And luckily for us, -42 divided by 21 goes in evenly. That's a -2. Okay. So then all I got to be able to do is figure out which variable is which and back substitute. So remember, this was my X column. This is my Y. This is my Z. So we know, looking at this very last row, Z equals -2. Okay. And then I think I'm probably just about out of time. So you can work backwards, and you'll have to go back to these equations and rewrite them with the variables, right? For instance, this second row is 1y minus 2z equals 4, right? Read it like that. And then substitute in z equals -2, and you'll have all 3 answers. Okay, so I'll do a little bit more about this for your Friday video, and then I'll make sure you know about the 2 special cases you might encounter, and we'll go from there. How's that sound? Is everybody okay? Just remember, there's only 3 legal moves. You can swap them, you can multiply by a non-zero, or you can multiply and add. Okay. Y'all are still sitting there. Normally you're running out by now. Is the bell late? Nope. All right. Well, I'm going to let you go. You should be able to do the 6.1 homework. So start looking there. Okay. Talk to you later.